Welcome to the Carboline Tech Service Podcast, the go-to industrial coatings podcast. Here are your hosts, Jack Walker and Paula Atzemis.
Be sure to hit like, subscribe, and set your notifications to on so you never miss any important YouTube content from Carboline. All right, joining us this week on the Carboline Tech Service Podcast is Pete Mitchell. Pete Mitchell is the Vice President of Business Development and Technical Management for GMA Garnet. Hey, Pete, how's it going?
Very good. Good morning, guys.
Morning, Pete.
Hey.
So, Pete, why don't you tell us a little bit about GMA Garnet, who you guys are and what you guys do?
GMA Garnet is a global mining, processing, distributing, recycling group. We have 3 deposits around the world. We process the garnet. We're actually 5 divisions. So we sell garnet to pretty much every country, anywhere in the world. And it's our material. We're one of the only ones that actually produce the material, package the material, put our name on the bag, and then stand behind it.
That sounds like a great style, a great operation. How long have you guys been doing that for?
A little more than 35 years. Our owner started this. He found a need for this years ago over in the Middle East, where they were doing so much oil and gas business, and didn't want to use sand. And so they got in and realized how efficient garnet was, and that started the business. It's been a success since then.
Well, Pete, how did you get in the business?
I started back in the early 90s. Garnet is also used for water jet cutting. And years ago, I ran water jet cutting business in Dallas, and I was introduced to garnet through that. I'm a wide guy. I like to know everything about everything. And so I played with the garnet in many different ways in the water jet, and then also used it for blasting in my shop. And the garnet companies came to me because they saw my testing and wanted me to help them, which eventually led me to moving into selling garnet. They ended up pulling me out of the job shop, and I've been selling it ever since.
And it sounds like now you've got a little more of a managerial style role. You've gotten a little bit out of selling, but you're able to keep your hands on all of that technical stuff, all of the testing and the research that's done with it, which has led you into some really great topics and some areas of research that have brought some new information to the industry. Can you tell us a little bit about some of that stuff?
Yeah, absolutely. We started off with, when we got to the point with this with GMA, I've been testing for years, but one of the key items up front was, where do we sit versus our competitors? And not to go out and slam the competitors or not to throw out anything crazy, but I need to know where I sit, apples to apples. If you take my competitor's product and use it to the optimal, the best performance possible, how do I sit next to him? And so we started off down that direction, everything from performance to consumption, all different, trying to get total cost per square foot, doing what everybody wants to know, looking for money. This then expanded into surface cleanliness and embedment studies and peak densities and all these other little niches. One, looking for an edge for garnet, but 2, really understanding the total concept and the thing from front to back. Even toxicology, I'm doing heavy studies on dust in the air, and with all the beryllium ruling and all the crazy stuff going on these days. I want to know. I want to know where we stand. So.
Well, that's an important point that you make. And I think that's one thing that we just need to review real quick, just to be said, is that when we're looking at these different materials in the industrial coatings industry, a lot of times we're talking about sandblasting. So there's lots of things that are important with all those different factors that you talked about. So I think first, let's talk about, using garnet for sandblasting in comparison to some of the other materials that we know about. So, whether that's coal slag or steel or sand, where does garnet fall in that range?
Garnet is a very unique mineral. It is a natural mineral, gemstone. Just like, I mean, the jewelry garnet is the same thing as the garnet we do. It's just broken down in smaller pieces. But garnet is very, very hard, for one. On the Mohs scale, diamond's a 10. Mm-hmm. Sand tends to be down. You get into the 5 to 6 range. Coal slag's around 6. Well, garnet can range from a 7 to an 8.5.
Wow.
So it's really, really hard. So you throw something at a wall at that speed, the harder it is, the more damage it's going to do. Mm-hmm. But also, garnet is a very, very tough crystal. It doesn't want to just shatter, and the friability level is very low. So not only the harder surface does work, but because it doesn't break down, it maintains its integrity. And when it hits the wall, it creates the profile. It generates the work. So the whole reason, I mean, that's our claim to fame, is that with a lot less product, you can do a lot more work.
So you mentioned a word in there that caught my attention that I know we've heard several times and we've talked about, the friability of the garnet. Can you get into a little bit about that? Maybe a little bit of an explanation for some of our, newer listeners that maybe haven't heard these topics before.
Absolutely. Friability is what, many people will put abrasives all in the same boat. You'll say, okay, it's all 30-60 mesh, and you figure that they all do the same thing. Well, they all have a varying level of friability. When it's the same as, for any of you golfers out there, you see a regular golf ball, and you see one of those little chalk golf balls. Look at what happens when you hit that chalk golf ball, and it disintegrates and it goes nowhere. I mean, if you have a crystal that hits the wall and is extremely friable, one, it's not going to either remove the coating or create a profile. Usually it's going to just disintegrate and create dust. Sometimes if it's very, very hard but still very friable, it'll hit the surface and it embeds in the surface. So you'll blast with it and you'll get all these little spots all over the surface. And so, I mean, the friability tremendously determines the amount of work that the abrasive will do when it hits the surface.
And that's a great point. And it was something that honestly I had never really thought about before. And I caught your presentation at Bring on the Heat, and it really caught my eye, because one of the things that you brought up is how that friability affects your surface cleanliness, because ultimately when you're blasting, you're trying to get a clean surface. So can you talk a little bit about how the friability of your blasting media can actually affect your surface cleanliness?
Absolutely. You'll hit it several ways. On some of the byproduct materials, like your slags and some of your other byproduct materials like that, they'll have the hardness, but they're very, very friable. You do several things. Because of the semi-hardness and the friability, there is a high tendency for it to embed in the surface. It also, because of the extreme friability, the dust just it's literally a cloud of dust when you're blasting. You go out with all the questions on salt. Okay, you go out and you measure an abrasive salt content at the gate of a plant, but then you don't think about, well, I'm in Corpus Christi and I'm going to blast on the wall and create this cloud of dust that then the dust settles on the surface. Well, what did it grab out of the air? So it can grab other contaminants like the salt out of the air and put on it. It can create just more dust. It can create embedment. Natural minerals too will do the exact same thing, but also if they have other weird minerals mixed in. When you do a natural mineral, it's not always just 100% what that is. And if you have softer or more friable materials in there, they can either stick on as a dust, they can embed, or even to the point, if they're really, really soft, they splatter on the surface. It looks like you shot a paintball at the surface.
Yeah, none of those are the desired outcome. We've all seen the tanks that people just keep vacuuming and blowing down and vacuuming and blowing down, and you just can't get all the dust off the surface or all the embedments out, and it really does cause a problem.
Right. I love a coating supplier that says, hey, don't worry, my coating sticks to anything. But to be honest, the coating is designed to stick to clean metal.
Absolutely. And all of the surface preparation cleanliness standards all say without magnification. So we're actually talking about some debris and stuff that's probably smaller. You probably need the magnification. Yeah. But the thing that's interesting to me is there's still a lot of it. And if you had a more friable, a media that exploded on the surface, if you had an adhesion failure, I'd be willing to bet you'd find some of that abrasive on the backside of your coating chip.
Absolutely. And we say without magnification. And so I can blast 20 different abrasives and onto a sample coupon for you, and you'll look at it and say, yeah, that looks like white metal, or that looks like near white. And then I lay all those on the table side by side and butt them up against each other. And you'll notice the difference that one will have graying to it, or one will have brown, or one will have green. They'll have a tint. And whereas before you looked at it and said, yeah, that looks great. Or if you're looking at a tank, until you did the two side by side, you don't realize, wow, that actually did leave something on the surface. And I mean, white metal says white metal. It says no contaminant. Near white, small amounts. When you actually really, yes, it looks good with the naked eye. Throw just a little simple 10 times on the surface and look at it, and you'll be shocked.
Yeah.
Well, especially there's the ASTM tape test for dust, for checking for dust, and I think the media that you use could have a huge effect on that test.
Definitely, absolutely.
So then you told us while we were getting ready is that your search for information about cleanliness led you down a different path. It led you to look at the effects of peak density. And I think even in your Bring on the Heat presentation, you talked about an amount of peaks that weren't even measurable by one of the industry devices. So if you could enlighten us on that a little bit.
Yes, definitely. And where we had noticed it with, we get out on a lot of job sites, and where this finally, I've always looked at cleaner surface, and Garnet leaves a beautiful clean surface. So that was always one of our things that we would hang our hat on. But we were getting out into areas where they kept telling us, no, you have to have higher profile. You need a 4 to 5 mil profile. Some of your high temp coatings, your TSAs, your things like that, you have to. And I said, why do you need such a coarse profile? And they said, oh, well, it won't stick. And it took me years to get them to finally say, oh, it's the pull test, right? So I got on a specific job, a pipeline job with some TSA on it. And I said, but if that's what it is, let's go try a lower profile, but a much cleaner surface. And so I did that, and the pull test was off the charts. It was night and day with it. And so I started digging further into it and trying to get better pictures of the surface after blasting. Well, what I came across with that is in the search for better pictures, I found some, a piece of equipment that they went in and they were actually measuring the peak density, because I'm curious about the profile too. When I did the test on it, all of my materials all tested 9999. And then everything else was like 2,000 to 6,000. And I went back to the manufacturer and I said, how can mine all be 9999? And they said, well, the meter only goes up 4 places. So we had them adjusted. They went and redid the software. And then I realized my products were going anywhere from 12,000 to 24,000 peaks. And what that meant was, and that's peaks per square inch. And so, in our testing, and I'm working on some papers on this, we saw a direct correlation between the higher the peak density, the better the adhesion, just more surface area to stick to, and not so much being this super coarse profile. And the other thing that it was interesting was some of the ones that I noticed that were the lowest peak densities, once I really got in and looked at it, I realized they were the ones that were so friable. I was reading the embedment, and the peak density where they were telling me, oh, that's a good 4 mil profile. I realized that profile wasn't more than about a 1.5 to a 2 mil with shards of the embedment, and that's why they didn't have any peaks. But it was an interesting study. To be honest, I think I opened up a can of worms, because now I've gone back, I've done a test with various TSAs, flame spray, arc spray, doing it on pipe and plate, but I'm also doing a whole series on high temp coatings to see truly how it affects right out of the bat. And I'm also looking down the road. What is this doing for your adhesion, where it's so critical on some of those more specialty coatings?
It's really interesting because you hit on something that I think is very important there. The reason that we want to have a deep profile as a coatings manufacturer is all we're trying to do is increase the surface area in which our coating is sticking to. So we can achieve the same thing with peak density. That could save a lot of contractors a lot of work out there.
Oh yeah. Oh yeah. And the thing about it, and here's your deal. When you say that and you push for a higher profile because you want to increase surface, and then you go just test the surface with SX tape, right? Mm-hmm. And that's what I'm getting at is if you go and read a peak density and you've only got 3,000 and you're like, wow, I really didn't increase much surface at all. And you're only reading the embedment on the top. I mean, you haven't achieved what you did. You made it to where an inspector signed off and said, hey, I tested it, it's 4, but you didn't do what you thought you were going to do. And 3 years down the road, you're wondering why it's coming off. So.
Absolutely. Well, Pete, you are a wealth of information about surface profile. Like I said, I've been in the industry for more than a decade. I sat in on your presentation at Bring on the Heat, and you enlightened me, and I had to have you on the show. So thank you very much for coming on.
Absolutely. Appreciate it.
And if you guys have any more questions for Pete, you can email us at technicalservice@carboline.com. Or Pete, what's the website for GMA?
It's gmagarnet.com.
All right. Well, thanks again, Pete. And then we'll see you guys next week.
Thank you for inviting me.
Thank you.